Hi, good afternoon, everyone, and welcome to the session of Tech Collider from Earth to Infinity and Beyond. I will talk about Industry 4.0, but before, we'd like to wait 5 to 10 minutes. Just start in 5 to 10 minutes. And also thanks to all the speakers that will be with us today. I will introduce them just in 5 to 10 minutes. Thank you. I see here that people are joining. We just wanted to say that we'll kick off in 2 or 3 minutes just to make sure everyone will be in the room. So, welcome everyone. I guess we can kick it off right now. Uh, it's a pleasure. I'm delighted to be the chairman and the chairperson for today's session. We'll talk about Industry 4.0 from Earth to Infinity and Beyond, which is very inspirational. We have 4 great speakers together with us. So we'd like to thank already both Nicola Redi and Nicola Paone, and also Marco Centurioni and Marco Potenza. I'll introduce you to the session. I'll tell you a bit more about myself and Plug&Play and what we do in the innovation field. Then I'll tell you a bit more also about a few trends that we see in Industry 4.0, but I don't want to spoil anything because afterward we'll have Nicola that'll tell you, who will tell you more about Industry 4.0 and all the trends that we see in the market. And eventually we'll go with the POCs. And the speakers, and then at the end we'll have a round table, and you can ask question at whatever time you prefer. I will address the question to the speakers during the different sessions. So I'll start sharing my screen.
Matteo, I just said, okay, perfect.
Yeah, can you see it?
Yes, we do.
Perfect. So welcome everyone again. I'm Matteo Pisani. I've been part of Plug&Play since 2019 now, and I'll tell you more a bit about Plug&Play as well in a minute. I started as a venture analyst, so an investor, and then I developed over the time as investor within Plug&Play, focusing mostly on insurance and everything that was actually crossing insurance, so also insurance and energy, insurance and health, and so on. And so I developed a few skills on how to invest in startups, and that's why I'm also here today and to present the POCs and the session. And as of today, I'm managing one of our offices in the south of Italy, and also our operation to expand towards central and southern Italy together with Plug&Play. Plug&Play started back in the 90s. Actually, it's a nice story. Our CEO, Said Amidi, he was a real estate man, and he owned a few buildings in the Silicon Valley area in Palo Alto, and he decided to rent this building to startups. So with the concept of co-working space that we know quite well right now, but instead of asking for money as for equity in exchange, and between the startups that have been part of that building, there were Google, PayPal, Logitech, Danger startups he invested in, and that's why it's being called Lucky Building. In 2006, we started actually with the venture capital fund, so in a more structured way to invest in startups. In 2012, we started with the open innovation part, so bringing corporates to meet the startups and also to develop business together. Up to 2016, where we had our first international expansions together with Daimler. We opened the office in Stuttgart, that now is the largest mobility platform in the world in terms of innovation. And then eventually in 2019, we also opened the office in Italy, but I'll tell you a bit more about our operations in Italy in a few seconds. When it comes to Plug&Play, Plug&Play is the largest open innovation platform in the world. We work with more than 550 corporates. We accelerate around about 2,500 startups a year, and we run 60 accelerator programs back in 2022. We invest in 250, 240, 230 startups a year. It depends on the year. We had so far 33 exits, and we have more than 1,000 startups active in our portfolio. And we work all around the world with more than 68,000 startups. They're all tracked in what we call Playbook, which is our digital platform. Here you can see a bit of our global reach. So we are present globally, mostly basically everywhere. From Africa to Silicon Valley, is our headquarters, up to China and Singapore as well, and then in EMEA. Here you can see some of our partners. We've been working with since the beginning. So from DHL, P&G, Microsoft, Adidas, and so on. And then here is our investment portfolio. So we have been investing since the 90s. We have more than 30 unicorns, which is a great milestone. We invested in insurance. We invested in all the verticals actually that our corporates play in, right? So we have more or less 18 verticals, and we invest in all these verticals. So we have Hippo is insurance, and we have Dropbox, Honey, and so on. Actually, the number is updated because we have 31 unicorns since a few days ago. For what concerns Italy, we started back in 2019, where we started our platform with food and beverage with Esselunga, Barilla, and Tetra Pak. Then we developed also the fintech part and the sustainability. Then the mobile accelerator, which is in Modena, the MBA, where we have also several partners. Then in 2022, we opened 2 new offices, one in Turin Takeoff and another one in Catanzaro, together with our strategic partner, Entofund. Now, getting to the juicy part, actually, this is the slide where we show all the verticals Plug&Play play a role in and where we work. But I wanted to use this slide actually to show you, in my opinion, how Industry 4.0 is actually impacting different industries, from agri-tech to brand and retail, energy, supply chain, maritime, mobility, new materials and packages, health, and so on. So, you know, this one is a trend that we can consider kind of cross-vertical for sure. And we will see it actually with the pitches that we'll have with the speakers of for the POCs, and also Nicola will tell you more about it. Speaking about Nicola, it will come right after me. It will tell you more about Industry 4.0. It's going to be our keynote speaker. So thank you again, Nicola, for being here with us. Nicola is our right now managing partner of Ventures Factory, as well as member of the investment committee of Vertis. Then we'll have 3 pitches presentation. The first one is going to be on gap and flash measurement system. We'll have Nicola Paone. Then we'll have actually Marche Centurioni, which HM Drive will talk about methods and systems for assisting the driving of vehicles, and eventually impact with long distance communication system with Marco Potenza. In the last 2 minutes that I have, I'd like to tell you a bit more about what we see in the market as of today within Plug&Play. As you have seen, we play a role in several industries, and over the time, we thought about it actually how Industry 4.0 is impacting, and we selected, let's say, 3 main trends, which would be connecting, optimizing, and automating the industries. With connecting, we have sensors, fog and edge, asset monitoring, and wearables. With the optimizations comes the technology of computer visions, as well as predictive maintenance, all the insights that you can gather by leveraging artificial intelligence, so AI, and eventually also the people management. When it comes instead to the automation part, automation is a broad topic as the other 2, but especially automation because it involves several pieces of technologies. Among them, we have robotics, additive manufacturing, digital twins, quality assurance, ordering and logistics, and then eventually, of course, cybersecurity and warehousing. So without any further ado, I'd like to introduce you to Nicola and his keynote speech. So Nicola, welcome on stage. I'll stop sharing my screen in the meantime, and the stage is yours.
Thank you, Matteo, and good afternoon, everyone. Great. Now I have the part to project my screen, and here we are. So again, thank you. As Matteo anticipated, I'm actually my main activity has been a venture capitalist. More precisely, I've been working in technology transfer venture capital in the last 15 years. The last fund that we have managed was actually a fund focused on Industry 4.0 technologies, spanning from robotics into all enabling technologies. And as every technology transfer fund, we do invest in pre-seed and seed rounds, many proof of concept. We did about 15 proof of concept, which means investing directly in the research team, just in the process of creating their own startup company and moving it forward. What I would like to tell you today is actually what I see Industry 4.0 is all about, what was in the past and what we believe is going to be next. Now, we always have referred to Industry 4.0 as an industrial revolution, the fourth industrial revolution, that is basically where the brand comes from. Now, we all know that actually at the very beginning we had human, animal, or let's say natural parts such as wind or water that were basically activating the initial machines that we had in the Middle Age up to the first industrial revolution, where actually the invention of the steam machine brought forward the ability of mankind to produce a significant increase in the amount of goods, either in the agriculture or the let's say industrial sector. And that was basically in the 18th century, while at the end of the 18th century, beginning of the 19th century, it was the second industrial revolution where actually electricity and chemicals were introduced. We got the electrical power became, let's say, was spread around. The modern industry in terms of serial production was invented in these days. Everybody remembers the Model T from Ford, which was actually the first volume car ever manufactured. Then we moved after the Second World War and we started talking about automation. So in the 60s, we had another industrial revolution where actually automation, making those machines, let's say, more and more faster in doing the activities and taking some local decision was actually the path that this industrial revolution indicated, which was taken later by the digital revolution, where we introduced the power of not really doing something but taking decision. That was the major change. While all the previous revolution were more related on doing same task faster, now we start the digital revolution introduced the ability to spread information and manipulate information at, let's say, a level which was never reached before. And Industry 4.0 basically comes later, where actually we combine the ability of automation with the ability of taking decisions. And the vision was to have a connected world where actually machines and human beings were all connected together, and they're basically working together in the perspective of what? Basically creating better productivity. Now, we have been witnessing in the last 100 years a growth in industrial production. This is actually the chart made by the Federal Reserve. It's a production index made by the Federal Reserve in the US. And that tells us that in the last 100 years, the industrial production in the US grew up by 10 times. And as you can imagine, the growth of industrial production was primarily driven by all those revolutions that we have seen previously. However, if you look at the last 10 to 15 years, we can notice that actually the growth of production is decreasing a little bit. Now, the World Bank basically gives us the same feeling. They made an analysis on how much global productivity increased in the 80s, 90s, early 2000, and let's say close by. And they actually discovered that the increase of global productivity decreased significantly by 3 times since the 80s. Now, productivity, which is basically the ratio between the output of the process and the input required, can be basically driven by three main variables. One is actually the human capital. So how efficient is the output with respect to the number of people and the skill of people required to manufacture or, let's say, deliver something. Then we have what we call capital deepening. Capital deepening is basically every time that you buy a new machine and every time you make an investment that increases productivity, that might bring to an increase of productivity. So we basically try to understand how efficient is the use of investment in increasing productivity. And the last variable is basically everything else. It's called total factor productivity, which also includes efficient in processes, the way you change the process and you make it leaner, etc., etc. Interesting, and these were the years when Industry 4.0 was introduced. The efficiency of capital deepening was in, let's say, boosting productivity was very low. So the question that we do have is, has the fourth revolution really happened? Now, on one side, we know that this is an average number, but it is about 500,000 on average that every company loses every year due to the lack of integrating machine on each other, integrating their processes. And as far as this is an average number, and the, let's say, in 95% in the world, companies are small, medium enterprises, not big companies. This is a huge number. So if you take that ratio, it means that there are significant losses in not having that integration inside the industries. However, on the other side, the average age of the industrial equipment that you have in a company is 20 years old. And those machines are not at all digital. And in some cases, they're analog and they do not have the ability to be connected into the world of Industry 4.0. That basically, as a consequence, we reduced that approximately 1/3 of global companies failed in introducing IoT in their processes, while 97% of companies fear that introducing IoT would lead to a severe problem in terms of cybersecurity. So the fourth industrial revolution is basically threatened by some significant challenges that we see here out of these numbers. Now, as I mentioned at the beginning, if we take a matrix and we try to understand how the various industrial revolutions were meant for, we basically discover that the first four revolutions primarily were focused on making single equipment faster in doing their tasks. So you want to increase productivity through doing a repetitive task faster and better. While the digital revolution introduced the concept of taking decisions, automate decisions, both at single equipment level and ideally at an integrated process level. However, in order to integrate the process, we needed to go through the fourth revolution. And the fourth revolution, on one side, wants to integrate all processes, and on the other, wants to keep the automation and the pace of automation of a single equipment the faster possible. There was a significant misunderstanding between those investing in Industry 4.0 in the last years, because many companies invested in just one step of their process. But as a consequence, changing one step of the process wouldn't lead to any impact to the process as a whole. And actually, productivity is the consequence of the whole process, not just one step in a process. So that was basically one of the reasons why industrial companies, while investing significantly in Industry 4.0, that didn't lead to an increase in overall productivity in the last years. What are the challenges now that we do see in this specific industrial revolution? On one side, we need to connect everything. So there is still a gap between having the whole processes being connected and just single equipments working with some decision-making processes. Decision-making is the other axe of evolution. We'll see that in a moment. Who is taking the decision? Is it a local decision, or is it the decision that is taken centrally? And those will lead to significant differences in terms of computational power, bandwidth, etc. Last but not least, we have always referred to Industry 4.0. However, we should not think about manufacturing only. There's far more, let's say, use of the connected world outside of the world of industries. So when it comes to connect everything, the first point, remember, we have 20 years old machines on average in our factories. So how do we make analog machines, let's say, connected machines? And on the other side, even if you have a digital machine, very often digital machines, they do have different standards. They cannot communicate each other. So if you have one machine from one vendor and then other machine from another vendor, making those two machines talking together is sometimes a little bit of a problem. Second, it's not just a matter of machines. In many industrial processes, it's the whole environment that matters. You, on example, have to connect climate control systems where actually the quality of the output of your process is also related to climate controls, which usually are not at all considered as part of the loop in making better products at the end of our processes. Third line, how do you integrate those machines, those equipment with the overall IT architecture of the company? If you want to control a networked system, you have to control through the enterprise softwares that you have already available. So one challenge is how do we move from the single equipment into something that talks easily within the whole IT architecture of your company. That leads to another stream of challenges. Bandwidth. Bandwidth is becoming critical, or if we look at the other way around, data compression. So we want to communicate a large number of data, or let's say reduce the size of those data that we are sharing among machines and sharing between machines at ground level, at fog level, and cloud level. In terms of connectivity, as many companies operate globally, they have a need of a global connectivity. They want to know not just what the different plants are doing in the different parts of the world, but they have to track their shippings. They have to know whatever happens to their product between themselves and their customers. And this has led, on example, to a huge stream of innovation in the world of space communication, which have been primarily focused on IoT connection. Last but not least, as far as we're talking about connecting, security of connection is, as also companies mentioned, very critical. So making the transmission of information as secure as possible is part of the resilience that is required for any Industry 4.0 network to work and to be reliable. In terms of decision making, which I would say where the brain is and how the networked elements are thinking, how do they act? For quite a long time, we thought that every decision should have been taken at cloud, which is fine. Many decisions should be kept there. As of today, many, Matteo mentioned artificial intelligence. Many artificial intelligence systems, many neural networks can't run locally. They have to be run remotely, which means, again, data transmission and optimizing those neural networks in cloud systems. And then all the issues connected to relying data on a cloud, which might be proprietary or non-proprietary. Second point is, which is vice versa, taking decisions as much as possible close to where something happens. Are we able to take decisions at the level of the edge? Level of the edge means, do we have the computational power to make an edge computer taking decisions with neural networks? Are we able to let the brain of a single machine being interconnected with all the other machines without talking to the cloud? So there's a sort of, on example, we are talking about a swarm of drones. If you think about a factory, it's like having a swarm of different equipments that have one specific task to be performed, that is the output, and they have to take decisions in, let's say, coherence with each other. Third, again, mentioned by Matteo, digital twins. We know that many machines, for many machines, we have data, but on the other way around, we cannot calculate all those data. We cannot measure all those data. There's a new stream of research and new stream of products where actually we try to have digital twins, not just for designing new products, but to follow the life cycle of every specific product based on a few parameters, few variables, physical variables to be measured, while all the other variables can be calculated again by artificial intelligence, so that we know what's the status of that specific equipment, if we have to run predictive maintenance, if there's going to be a potential failure of the product, etc. And bringing digital twins into a chip that is fit into one specific machine, such as an electric motor, this whole set of, let's say, the new set of challenges. And last but not least, orchestration. If we are moving towards decision making which is spread around, how do we orchestrate those edges? Is there a possibility to run very complex calculation using different edges and distributing calculation to the single edges and then taking a decision at the level of one single edge? And what happens if one edge doesn't work? Is the whole system still resilient? So those are the challenges that we see in the decision-making side of Industry 4.0. Then we said beyond industry, definitely healthcare is one area where Industry 4.0 as a concept would provide significant benefits. If you think about a hospital is a huge production line. You have different machines, usually coming from different vendors with different standards. You have queues of semi-finished product, let's say patients. Every patient has to go through a specific process, going through diagnosis to operations to recovery, whatever. And so hospitals nowadays are not run as integrated processes, but we do have the technical capabilities on doing it. So the next wave is to integrate digital healthcare and connected healthcare, on example, on clinical engineering. Precision farming is another area where the ability of taking local decisions, connecting objects, etc., is getting critical and critical. And of course, the world of energy, where actually we are getting more and more acknowledge that energy is a very complex system in these days. You have local production, central production, distribution of energy. Renewable energies, they have their own problems in terms of their peak of productions, which are not connected to the peak of use of energy. So how do we handle grids which are getting more and more complex in terms of balance, in terms of the rate of production, in terms of the rate of consumption? And last but not least, mobility. Again, the ability of handling many different objects running together on streets, on every means of transportation, in order to make faster, cleaner the way we transport goods and people. But beyond those challenges, we have another couple of challenges. First of all, the climate challenge. Now, if we take the IT sector is the third global energy consumer after China and the US. When we talk about energy consumption, it's basically half related to the manufacturing, the use of devices, but the other half is linked to data centers and networks. So basically, half of, let's say, the overall IT energy consumption is dedicated to handling and transmitting information around networks. And to give you some idea in terms of pollution, CO2 emissions by data center were accounted in something which is close to 200 megatons of CO2 every year. So that is another significant area where Industry 4.0 can bring, say, further challenges for researchers to find, let's say, solutions and better technologies. Last but not least, where do we test? Because we are here talking about proof of concept. Now, if I have a proof of concept, I have a technology in lab, in a business, in an industry where actually our goal is to integrate one specific technology into a very complex network, because that is Industry 4.0. So how do we test the real impact of a new technology in such a mass of networked system with distributed intelligence? Definitely, we have to make tests in a lab, but a lab is a very clean and protected environment. So every result that we find in the lab can be reliable, but wouldn't be, let's say, as effective as what we would have in a real working environment. We had seen an increase of what we call demo centers. There are several demo centers where actually real equipments are shown and demonstrated. So we are getting out of the lab, we are getting closer to the real operational environment, but again, every single equipment is tested on its own. So we don't see the real impact on the overall productivity of every new technology that we introduce in the demo center. Therefore, the ideal scenario is to have what we call integrated model centers, where actually we replicate the real world complexity in, let's say, in a controlled situation with all the different hardware and software, let's say, equipments that real life would, let's say, would offer to the researcher, and have a real valuation of what the impact of the new technology would have bottom line at the end of the integrated process. And this is another challenge for researchers. Where do I find such integrated model test centers where I would know exactly how well my Industry 4.0 solution would work in an integrated and complex environment? So this is all from my side. Thank you very much. And Matteo, I leave the floor back to you. Thank you.
Thanks to you, Nicola. Perfect. So I guess in the meantime, we can actually kick off with the next presentation, and I can jump into the POCs. So I'll actually leave the stage to Marco Centurioni to introduce HM Drive. So Marco, the stage is yours.
Yeah, thank you everyone. Hope you can hear me well. Thank you. Okay, thank you, Matteo, for I'm going to share my screen. Thank you, Matteo, for the introduction. Please let me know if it's working.
Yeah, it's working.
Yeah. All right. Okay. So once again, thanks for the introduction, and thanks also to Nicola for the interesting presentation. I see a lot of touching point between our project and the concepts and the trends that he has highlighted. And so let's start. So basically, I'm going to introduce you HM Drive, which was born back in 2018 as a research project at the MOVE research group at Politecnico di Milano. But then also HM Drive evolved in a spin-off company. I want to start with like a tricky game. I would like to ask you to try to read all the words inside the slide just in a couple of seconds. I think that if you try, probably you're not going to be able to catch all of those information, because it's really hard to get a lot of information in very few seconds. However, we do that many times. We do that especially while driving. We often try to get information from the smartphone, from the infotainment system, and also like information about the environment and the outside context. And we do that for many different reasons. Of course, we want a very good driving experience. We want a nice infotainment. We want to use our smartphone in order to keep the connection with other people and to get information. But then also we have to get information related to the vehicle status, the context of the vehicle, and this is going to be a need higher, like bigger and bigger, because the advanced driver assistance systems and the higher level of autonomy will need to have a good interaction between the driver and the vehicle. This is exactly the final step that Nicola mentioned with respect to human and machine interaction. And then, of course, we have to get information for safety purposes. This is a very crucial point. Still nowadays, we have that more than 20% of the accidents are related to visual errors. And so basically the visual aspect of catching information is really crucial. And this is true for any type of driver, no matter the type of vehicle and the context. This is true for a race driver on a sports car, because he or she wants to get the right information at the right time while driving really fast. This is, of course, true for industrial vehicles, for improved productivity, and also for safety purposes. And then, of course, it is also true for everyone on a normal car, because we want to have that mix of information that I was mentioning at the beginning. The problem is that basically the market and the technology nowadays is proposing just one solution, which is you need a lot of information. All right, I'm going to give you all at once. So we are seeing larger and larger screens for industrial vehicles. So we see a huge number of monitors because we have a huge amount of data, a lot of knowledge, a lot of information, but it's really hard for the driver in this scenario to catch the right information and not to be distracted by this huge amount of information. And so the idea behind the project HM Drive was that this is really not a solution, and that AR glasses, which are also called head-mounted display, so HMD, are a good and the right solution, because these devices, which are basically a see-through display always in front of the eyes, can make, let's say, the world a three-dimensional screen, which means that the information can be physically placed in the environment. The information are always shown in the user's field of view, which means less distraction, no problems of occlusions, and so on. And then, of course, it's going to be a digital screen. So there's the possibility to highly customize the interface. However, the AR glasses cannot work properly on a vehicle. In this short video, you see the cones, which should remain fixed on the ground. However, they are just like flying and entering into the vehicle. That's not what, this is not the position that they had to keep. And this is a problem of localization. The main issue for providing a great visual experience is to perfectly and accurately localize the head-mounted display, so the AR glasses inside the cabin of the vehicle, and then also to localize the vehicle in the outside environment. All the built-in algorithms and the existing solution were not thought for this, and so this is the context in which we decided to work. And HM Drive is basically an innovative method for enabling the usage of AR glasses, or more in general, head-mounted display, as a vehicle driver interface in moving scenarios. How is it possible? Well, in simple words, not to be super specific, super detailed, the goal is to position the glasses inside the vehicle, and then also to position the vehicle in the outside environment. We do that combining different technologies, different sensors. We use computer vision approaches and sensor fusions in order to combine the information coming from different sensors. By doing that, we are then able to provide some information both inside the vehicle, we call them vehicle locked, and also information which are placed in the outside environment. It's quite easier to let you to see this video where you can see that there are some arrows and some signals in the outside environment. They are placed as a GPS position, so they are geo-localized, and then also there's a dashboard, an augmented reality dashboard, which is linked to the cockpit of the vehicle. In the video you don't see the transparency, but in a real scenario that screen is going to be transparent. So this is the concept that you can have the right information placed in the right place, and each type of information is going to be always in the driver's field of view. So I was already anticipating this slide. So there are different advantages, that just to mention some of them. You have the possibility to highly customize the design according to the context, according to the user's preferences. The interface is, of course, dynamic, which means that according to the status of the driver, the status of the vehicle, you can change, for example, the transparency, the text dimension, and so on. And then, like, the AR glasses are thought for a 3D projection, so you can place information in the right in the right position, both inside the vehicle and outside. Going on, all right, with respect to the existing technologies, so the dashboards, the virtual cockpit, and the head-up displays, which are thought for projecting on the windshield, this solution enable the possibility to provide safely a lot of information and to make the understanding of those information easier for the driver. We started in back in 2018, and then the POC grant let us to move on to increase the technology readiness of the technology, and then that brought us also to the incorporation. In May last year, we incorporated HN Drive, and we have been selected then by the Motor Valley Accelerator that Matteo was mentioning as a beginning, since Plug&Play is the managing entity of that accelerator. And so now HN Drive is also a spin-off company of Politecnico di Milano. We are now at Technology Readiness 6. Here you can see the setup that we used for the videos that I've shown. And next year and this year, we are planning to close the first fundraise and to complete the product development in order to reach a higher level of technology readiness. What we are basically building is a platform, a software and hardware platform, which is based on our algorithm for the positioning, but then integrates the sensors and the other components which are required for the experience on any type of vehicle. It's going to be a very flexible platform. It can be used on different type of vehicles, and there's the possibility to build on top of that different type of user interface and user experiences. For this reason, we imagine to be able to work on any type of vehicle. Right now, we have a couple of projects running on sports car and industrial vehicles, but in the long term, let's see, we truly believe there's the possibility to apply this technology on any type of vehicle. Just a couple of more videos, then I'm finished. The sports car use case, in this scenario, the augmented reality glasses can the driver see a competitor or to see some information related to the telemetry in order to improve the driving experience. While in the farming sector for tractors, there's the possibility to virtualize the screens, so no more occlusion, and to provide the right information at the right time, always in the driver's field of view. This is the team of the project, a mix of academic, of course, Professor Sergio Savaresi and Professor Matteo Corno are the key advisors of the project. And then the young team, myself, Luca, and the core team developing the project, and now working also on the spin-off HN Drive. These are my contacts. I would be really happy to keep in touch with whoever is interested and to answer any questions. So please add me on LinkedIn or write me an email. Thank you very much.
Thanks to you, Marco. Actually, it's great to see when our alumni startups actually have the time to pitch and actually attend these great events. So great to see you again, Marco. Then for the next one, we have Marco Potenza, who will pitch the PhD of Impact. So Marco, the stage is yours.
So I will deal with the world of global connection. In particular, we are developing a method and a technology for parallelize and is it? Do you see my screen?
Yes, we do, Marco. Go on.
Okay. Sorry.
See your presentation.
Okay. So to parallelize the information transmission from satellite to satellite or satellite ground or ground satellite for satellite constellations in view of these new technologies of global connection and space-based internet. Space-based internet is technology, a framework that is growing up in the last 10 years, let's say. And the aim is to build a structure that are expected to be much faster than the fiber optic connection and much more usable from ground, from everywhere. The idea and the need, the opportunity to build this kind of architectures comes from the increasing demand of internet access, together with the decreasing launching costs in orbit. And so a number of companies are now uploading or even realizing and designing, depending on the stage, this kind of systems that consist of thousands of satellites in low Earth orbits. And what is expected in 2025, for example, is to have more than almost 20,000 satellites in lower orbits just for building this space-based internet. But in future, some ideas are that these satellites will increase in number up to more than 100,000. Since we are thinking to something that is basically costly in terms of produce and launch, keep in mind that launching now can approximately cost something like $20,000 per kilogram. So one satellite is in the order of $5 million to be launched, only to be launched in orbit. Reducing the number of orbiting units will have a huge impact on the constellation. And one of the main limitations of these constellations is that to cover the Earth from low Earth orbits, we need a high number of satellites that is of the order of, I said, 4, 5, 6,000, but even larger. And the actual challenge that companies are facing is the access time to each satellite. From one position on the ground, I can see a satellite for at most 10 minutes, typically 5, 6, 7 minutes. So I will be connected to the web of satellites instead of each satellite as it is mainly now working something like this. So the web, the network is needed to be highly dynamically evolving with time. And basically, it is expected that the network itself will install edge computing on board the satellites to pre-evaluate the information to be uploaded and downloaded. So the need that we are facing and try to assess is to multiply the information transferred from one satellite to the other, so to make easier and faster the dynamical operations of the network. So actually now the connection are expected to be optical from satellite to satellite. We work in the vacuum, so optical communications are very effective. While by contrast, downlinking signals with visible or infrared radiation light is much more difficult due to the presence of clouds, haze, or any other disturbances that our atmosphere and its components can bring along the life path. So now, basically, there are some studies to downlink information optically, but basically the satellites now and in the next future will downlink information by using radio waves that are almost saturated as a bandwidth. So we need to also to multiply and multiplex the information also in the radio waves to downlink signals. And so our solution, that is covered by 2 PCT patents, is to multiplex and demultiplex many transmission channels in the optical or radio waves bandwidth, by means of the proper shaping and proper detection of laser beams. The idea is to send these peculiar laser beams from one satellite to the other, so to and fro each satellite, so building up the network. And so we can think about the possibility to send a laser beam from one satellite, typically a 1 centimeter laser beam in diameter, will propagate at 1,000 kilometers. That is the typical distance of these satellites, hundreds of kilometers, 1,000 kilometers. And the beam will increase in size up to 20, 30, 40 meters in diameter. So the possibility to catch all the signal coming from the first satellite is negligible, so it is impossible to do. And so we developed a method that allows to demultiplex locally the information transferred by each wavefront. So we can send several wavefronts with different features, and so to demultiplex the information coming from each beam at the receiver stage. Before starting the POC project, we just realized the laboratory proof of concept with 2 parallel channels at a negligible bandwidth of 1 kilobit per second with a protocol of on-off keying, so to switch on and off gates, let's say. And the system was relatively simple, and it allowed to propagate 2 parallel signals with 2 ASCII character strings that have been sent and read with a bit rate of lower than 10 to the minus 11, so a good level of bit rate, thanks to one of the peculiarity of our technology, that is a control laser beam. By testing the stability of the system in terms of instabilities of the laser beam pointing direction and the influence of atmospheric or air fluctuations, the bit rate with our method will have been maintained down to less than 10 to the minus 11, while without integrating our system, the information would have been completely destroyed. So after this proof of concept performed in my laboratory, we applied for the funding, the ministry funding, with the project Impact, and we realized a system that is a proof of concept, again in laboratory. Of course, we cannot operate directly in the space, but we built a proof of concept in laboratory that I would call a hardware twin of the system in space, or what is sometimes called analog model or analog twin, where I use the word analog, not in contrast to digital, but in the sense of an hardware system that is reproducing all the conditions that we meet in space. So we built a laser beam that after 1 meter of propagation is reproducing the divergence of the beam after 1,000 kilometers in space. We operated with a detector that is as small, relatively small as it could be a detector in space with respect to the beam, and the transmitter behaves like a transmitter in space. So we fully validated the technique by sending 4 parallel channels at some tens of megahertz bandwidth, transmission bandwidth. That is also a small bandwidth with respect to telecommunication, of course, but the technology and the architecture of our system was thought and realized in a way that meets the state-of-the-art needs for devices currently operating in the telecommunication technology. So now we are going further, thanks to the development just obtained with the ministry funding, and so we are working again with 4 parallel channels but now at tens of gigahertz with a differential phase shift keying instead of the on-off keying. And this way we reach the cutting edge technology of the telecommunication networks. So what we will do with the next step is to provide a full validation of the technology with the current needs imposed by the telecommunications, reaching the TRL4 at 10 gigahertz. So we give guidelines for the engineering of more than a prototype, let's say, so towards TRL5. We will give and we will get and provide information useful for companies to implement prototypes. And we will test our prototypes or proof of concepts towards prototypes in real relevant environments. So we will reach TRL5. We are currently co-developing the technology by means of a contract with a space optics company that is qualified to realize space instrumentation, optical space instrumentation. So we will end at the end of this project, we will produce a prototype that will be space qualified, and with this process we want to meet the sector leaders to implement this actually in space. Sorry. Parallelly, we are discussing for making tests directly in space after realizing these prototypes. Of course, it is not a straightforward way to proceed, but we have contacts and we have ideas how to test the same technology from one satellite to the other and from one satellite to Earth by also integrating some kind of edge computing at the level of the satellite. So going towards a higher TRL and basically to go towards the real environment where this technology could be useful. So to better meet the needs of the principal actors of this on this world. So I thank you for the attention, and I will be glad to answer your question. Thank you.
Thanks to you, Marco, and thanks for joining us today. I'll see you right after at the round table. We have the next speech and the last one as well with Nicola Paone with G3F. So if you allow me, I'll leave the stage to Nicola, and welcome with us, Nicola.
Thank you. You probably see my screen, correct?
Yes.
Yes. So good afternoon, everyone. And now my talk will bring us back to the manufacturing environment, and in particular to the shop floor where operators are working. And what I will present is G3F 2.0, which is a new generation of portable laser scanners for gap and flash measurement. This work was developed at University Politecnica delle Marche and later carried on by a startup company. So let's talk about the industrial problem. We are in the manufacturing sector. We are in particular in the assembly lines, where operators, human operators and not robots, and this is the state of art everywhere in the automotive sector, human operators perform assembly operations of doors, lights, aesthetic components on the car frame. And this is a picture of the real environment where people is working. Why not robots in the very last part of the assembly line in automotive sector? Because the variety of cars that are being manufactured is so large that it is extremely difficult and not efficient to automate it. While they do the assembly, they need to measure the gap and flash. What is the gap and flash? It's actually the alignment between two adjacent parts. For example, this is a picture of a door with respect to the frame. Gap is the horizontal alignment in the plane of the metal, while flash is intended as the alignment in the vertical direction. It is not only a matter of aesthetics, which is important. It is also a matter of functionality, because the sealing system works better if the alignment is correct. Actually, this is a measurement that is done during the assembly process, but actually it is also a quality control. And in fact, what we are dealing about is inline quality control in the perspective of zero defect manufacturing. Zero defect manufacturing is something that in the manufacturing sector is being discussed. It represents an asymptotic tendency towards a production which doesn't produce any defect, which is impossible. However, improvements are always necessary, and the developments we will talk about are related to that. In particular, human operators and Industry 4.0. Actually, if we think of the digitalization of the factory environments, human operators are the less connected element. Any process can be digitally connected, but to connect digitally a human operator, it is not easy. So what we're addressing is to provide technology to human operators to let them perform their task while providing data to the system, being connected to the system, and being connected bidirectionally. What we will discuss, or I will present very quickly, is the state of art. The state of art in the car sector is that they're using manual devices like feeler gauges, calipers. Even if some attempts of using instrumentation, and in particular laser instrumentation, has been undertaken by several manufacturers. However, most of the instruments that are available in the market still have a cable, still are derived from laboratory devices, are heavy, not ergonomic, and do not satisfy the requirements of the operators which are performing their work and need a small, easy to be used instrument. This is what was developed by us within a European project. We were within Horizon 2020. And in 2018, the project developed and brought to a TRL of about 3 a concept. This concept was based on a laser triangulation sensor, which is a state-of-art technology that can measure geometrical features without any contact. We integrated a laser line triangulation system within a smartphone, and the smartphone was the edge device which provided computational power, connectivity, a human machine interface, and therefore this idea was perceived as an interesting idea by the industrial partners that we had, and it was filed a patent accepted in 2019. The project Goodman ended, and we were in the phase of validating the idea in an industrial environment, in particular at the premises of Volkswagen, where this idea was brought to a TRL in between 5 and 6. This patented idea was ready to be developed into some industrial product. The pandemic impacted on the series of events that we were planning. And actually in 2020, we created a startup company, because it is a spin-off of Università Politecnica delle Marche, which undertook the task to bring the design to an engineered device satisfying requirements which were continuously evolving from potential customers, and bring this to the market. And actually, this is the roadmap that was followed by us. And actually, the support of the proof of concept happened during this phase, in which the startup company was already operating with the university as one of the members of the society. Now, what is it now? USensit, which is the startup company created, has completely redesigned the G3F. The concept has evolved into a wireless industrial IoT edge device, which is compliant to the major industry standards. What is this technology in brief? It is a small ergonomic device, which is a wireless device with computational power on board. It contains a system of modules specifically designed to acquire and process images produced by the laser line triangulation system. And this becomes a tool in the hand of the operators, able to detect geometries, which are mainly profiles, and to compute to measure gap and flash from the profiles acquired, and provide this information either to the operator through a small human machine interface, which is a small display, but moreover to send the quality control data acquired to the manufacturing system, and therefore allow a full digitalization of the process. Now, which is the potential of this device? Actually, it is not derived by a laboratory device through an exercise of reducing size and so on and so. It is completely redesigned. It has been conceived for the operators. This is why we spent a lot of efforts in miniaturizing all the electronics, the optics, and providing the user experience something which is really usable from operators. There is a continuous feedback from the operators that are using the first prototypes which were prepared. What is on the market, the potential competitors? The potential competitors are present on the market mainly with three main companies: Micro Epsilon, Third Dimension, and NextSense, which produce laser line systems which can be portable. But if you see from the pictures, all the systems produced by the competitors on the market are heavy, large, and not easy to be used. At the end, they are not accepted by the operators. While what we are producing is really small, it fits to the hand, it can be put on a belt and from the operators, taken when it is necessary and put it back as a small tool. It has been conceived mainly for the automotive sector, but actually we are seeing and receiving requests also from the appliance sectors and from the aeronautic sectors. Sectors in which geometrical aspects, alignment between parts are relevant. And this is jointly analyzed. These sectors require manual operations. This is the target market that we have in mind. If we focus to the automotive sector, worldwide, there are about 500 factories which produce vehicles. Europe still is leading the worldwide production of vehicles because we have more than 250 factories operational. And the majority of them, 140, produce the full car. If you consider that in each factory there are at least 2 lines per factory, and on each line we plan to have at least 10 G3F per line, actually there is a potential market of about 300 devices in Europe. Therefore, the spin-off we think that the potential market that we could address is about 25% of that, achievable in 5 years, in a situation where the customer is a business, is an industrial OEM, is a car manufacturer. This is something that, in our mind, represents an interesting experiment about the triple helix in action. The interaction of university, where the idea was generated, of public bodies, and at first the funding was coming from the European Commission, later was coming from POC Faster, and business because the customers require a company to interface and to purchase a system, so, like a sensor. Now, therefore, we are in the phase where the idea has been transferred to the spin-off. The startup is on the market, is searching for private investments, is in the phase of advanced engineering, is in the phase of industrialization with all the supply chain which is being set up. We will have to face the certification, which is a real challenge for a new device, which is a Wi-Fi device involving laser systems used by operators. And then we will have to invest a lot in marketing, sales, and post-sales. Actually, this was the story, and I think I can leave the floor to my colleagues, and I thank you for your attention.
Thanks, Nicola. It was great to hear your pitch. And actually, we are at the end of the pitch sessions. Next session will be actually the round table. So I'd like to invite all the speakers here together with me, so we can actually kick it off with the round table. Hi, Marco. Hi, Nicola. I think we're missing Marco Potenza.
Can you hear me now?
Yes, we can.
Can you see me?
Yeah, we can see you as well. So guys, be patient as well with me because we have two Nicola, two Marco. So there could be a bit of confusion here, but I'll call you with the last name as well. So actually, Nicola Redi, I wanted to use one of your questions, which I found super interesting during your pitch, which was actually talking about whether the fourth revolution really happened or not. And from this one, I would like to start, right? So we have seen several pitches and several POCs, brilliant solutions as well. And also your presentation was super inspiring and gave us an idea of actually the trends and what we should look into in terms of technologies, in terms of industries, and also a bit of history, right, on how we got here today. But the question still stands, right? So has the fourth revolution really happened? There is a lot of resistance right now. We've seen that, maybe not a lot of awareness, which was one of the topics that you have mentioned. But I'd like to ask the question also to the other speakers and ask whether these revolutions really happen. If not, why? So what's your opinion? So maybe Nicola, Paone, you want to start?
I can start. This is a question I always put to myself. In my understanding, in my experience, revolutions are slow processes, especially technological revolutions. If we consider the manufacturing environment, which I know quite well.
So Nicola, I think we have a bit of background noise. So if in the meantime, like while Nicola speaks, we can mute ourselves, that would be best, I guess.
Can I try again? Is better?
Yes, it's not. I'm not sure from where it's coming. Maybe from you, Marco Potenza. I think there is a bit of background noise.
Matteo, I switch off the microphone for you. Don't worry.
Okay, thank you. So I was saying, in the manufacturing sector, there's certainly a strong movement, a strong interest about digitalization. But as Nicola already was saying, we have a lot of legacy equipment. And therefore, this legacy equipment is rather complex to be digitized efficiently, and this requires investments. Then, as I was mentioning, human operators. Human operators, in my experience, are the weak part in the digitalization process. Even if it is not conceivable that the future of manufacturing will be without operators. Operators are smart, edge humans, and therefore we need to have operators. And this is why we are investing, for example, in that direction, to provide new tools which could provide and recover the capacities of operators. It takes time. Therefore, is the fourth industrial revolution accomplished? Not. But we are doing that all together, and it is a true process. I don't think it can happen all of a sudden in 10 years. One last remark. We produce a lot of data. I deal with instrumentation. Whenever we talk about data, in the factory, there is a big concern about clouds. Sending proprietary data, sensitive data to the cloud is at least perceived as a security issue. And therefore, edge computing and private clouds probably are the way to go. Edge computational power could be also networked. Many different processes could be exploited more efficiently in a networked fashion. I'm a mechanical engineer. I have only the feeling that this is possible. However, I hear and I see that there is an interest of going in that direction. And this is why we are at Ancona, in the Università Politecnica delle Marche, and in the spin-off Usensit, we are investing into laser instrumentation, which is an edge device in the hands of the operator, which provides connectivity, small computational power, and so on and so on. So I don't know if this is responding, probably not, but it is freezing.
Yeah, no, of course, there's not a right or wrong answer actually, but I think you you mentioned a few super interesting things. Actually, the last one was the sensitive data as well. You know, that's one of the reason of the low adoption that actually Nicola mentioned before. But I also wanted to ask Marco Centurioni and Marco Potenza, who actually are also inventors here. Do you feel part of this revolution? Do you feel the barriers right now, or like resistance from the industry, or something that you don't perceive?
I can go on. Well, I really like the answer from Nicola Paone. In my opinion, the main problem regarding the adoption of the industry 4.0 was related to not putting at the center the final users and using an approach which was more tech-oriented with respect to user-centered. And this was probably one of the main issues related to the fixation of users and operators, because, like, especially in Italy, I believe that this market is probably very linked to fixation and to be a very slow and static environment. It was hard for people to address new technologies, to get the right potential and not to feel like uncomfortable with those technologies. So in my opinion, one of the key elements for the adoption of new technologies and for the real implementation of like the IoT, but now also the new technologies coming. I'm also thinking about the wave of AI. I truly believe that the key point is going to be how companies, how tier one company will be able to put at the center the final users. I really like what Nicola Paone is doing. It's similar to what we're doing, because we truly believe that there are many situations in which human operator cannot be substituted. There's an added value to keep to keep the person in the loop. And so we should be able to provide them the right tools and the right way to get to understand the value of using that tools. So all my thoughts are linked to the user perceived and the user-centric design of these solutions. That's the key point in my perspective. And I do not have a final answer. Again, it's quite hard to answer. I will let to Nicola Redi a final review of our thoughts.
Marco, you're mute.
Yeah, that's all. That's all from my side.
No, I would say Marco Potenza. See, there is a confusion because 2 Marks and 2 Nicola. No, I was saying Marco Potenza is, if we can unmute Marco Potenza in the meantime, so that we can hear him as well.
Sorry. Okay.
Perfect.
Okay, thank you. So I fully agree with Nicola Paone and with Marco, and I also recall something that Nicola Redi told before at the beginning. I can add a couple of thoughts that I am facing in the last years, and let's say 15, 20 years, interacting with industries and the world of technology transfer, that especially in Italy, but not only in Italy, it is quite difficult to find effective interaction over the academia and the industry. And okay, this can be due to many different reasons, of course, and many faults or many missing. But one point that I consider in the last year is that the most innovative technology we want to introduce in a factory, in a company, the most expensive it is. And this means that automatically let's say the involvement of the technical part of the industry decreases and increases the involvement of the financial and let's say economical part. And I feel also by talking to other colleagues, also in economy and so on, that a very big issue is that by letting apart the technical personnel and technical guys will not allow to the financial part to better access the strategy, the potential, and the effectiveness, the future developments that could be allowed by innovative technology. And I don't want to draw conclusions, let's say, but one can imagine that the slowing down in production could also be due to this kind of difficulty and could also motivate the lack of increasing technology and the use of old machinery and so on, just because the connection between the technical and the financial part is diverging, let's say, in my opinion. So the point is that it is very difficult from the technical guy, from the scientist, for the engineer and so on, to appreciate their economical and financial needs, and it is very difficult from the management to understand the needs and the potential given by the new technologies. This is my additional thought that I want to add to what has been said, that I completely agree about.
Thanks, Marco. I agree on what you said. Actually, Nicola, if you wanna give also, like, you know, your opinion here, to synthesize what has been said, and afterward I also have a question for you. But before, I also wanted to say to the audience that we have the questions section here that is open. So whenever you want to ask a question, please do so. Our speakers are here also to answer your questions. Nicola, please go ahead.
Oh, thank you. Actually, just commenting on what Marco Potenza was previously saying, well, I'm a little bit in the middle because I'm an aerospace engineer and the interview is not in finance. So I'm in the middle. I have to take care of the economics and the technical part of it. But I definitely agree. There's whenever it comes to innovation in the broad sense, so it's not just Industry 4.0, it's a matter of speaking different languages because we're dealing with the complexity, which is even the complexity from a technological point of view. Now, I'm really on the same page of what both Nicola Paone and Marche Centurioni said previously regarding the relevance of having the human being in the center, and that sometimes we are lacking in delivering results just because we forget about this, let's say, tiny element and we keep it out of the loop. So that's right, it's often outside of the loop, and this is basically why many processes are not working. Interesting, if there's now a buzzword that I would say is even buzzer than the Industry 4.0, which we generally we talk about deep tech. And when we talk about deep tech, there is a little bit of confusion because many people say deep tech is just about science. So, you know, all investments are going that direction. But in reality, deep tech is at the convergence of three different approaches. We have definitely science, but we have engineering in the sense of creating new products, and we have design thinking. So there is an understanding that actually when it comes to innovating through deep technologies, it can't be just led by the scientific side, neither from, let's say, the system integration side, but everything has to start from a design thinking approach. And this is really something I think where actually probably there has been an understanding what was not working in Industry 4.0. Nevertheless, last point is it's definitely a lack of putting the human being in the middle, but there is also a huge lack of understanding the process as a whole. So many people say, if I change something, if I introduce a new technology feature, then I will have a better results. But if you, every innovation is garbage in, garbage out. If you keep a process which is an unreliable process, is an ineffective process, whatever you're trying to do, whatever you're trying to automate, if you don't rewind the process, you won't have results. So this is another piece of another weak point in Industry 4.0 revolution. Many companies or many institutions never change their processes. They just introduce technologies, and you can't have any results if you don't change processes and you redesign processes together with introduction of new technologies.
No, thanks, Nicola. I think, you know, like with this first question, we gave kind of a perfect understanding or like overview of what are the pitfalls that we see in the market. My next question would be, actually, I wanted to follow a thread starting from what you said before during your presentation. One of the trends that we have seen in the market is also machine-to-machine communication. I've seen it also like in the insurance side, right? Because machine-to-machine communication poses also a threat, and it's something that you need also at some point to make sure that it doesn't happen, right? That lack of information, leak of information when the two machines communicate. And you also mentioned that actually, besides the failing in the adoption of IoT devices, also like more than 90% of people like are fearing, or companies are fearing to introduce IoT also because of potential leak within the IoT devices, right? So everything is all these data points are slowing the adoption of what we consider Industry 4.0. And now, Nicola, moving from what are the pitfalls, what would be actually for you potential solution to this one? It could be education, raising the awareness, or what do you see starting from the pitfalls like to be potential solutions? And then also we'll go also with the audience as well, with the rest of the speakers, sorry.
Well, I would say I was a little bit impressed to the 97% concern about the data security. We all know that there is a concern whenever you have a data and that data can be manipulated or stolen or whatever else. But of course, there are also countermeasures that can be introduced. So in some cases whenever there's a fear, there's also a lack of knowledge. So if you're fearing something, you should be thinking about the countermeasures. and not just say, well, stop it, I won't go forward with this new innovation, because otherwise we would have never innovation. So your point, Matteo, is definitely right. So if we increase the awareness, definitely on the threats, but on the other side also the countermeasures that we can implement to have something, let's say, to innovate and to introduce new technology, that would definitely help. This, I believe, it's one point, and I would say, going back to a previous point, when it comes to education, there's also education of, let's say, I said previously, speaking different languages, or let me say, have both a vertical and a horizontal side. So don't just be on your silos. Innovation is something that requires to open your mind, to think out of the box, and to put always yourself in the shoes of the other counterparts. Otherwise, you can't innovate. And this is something that has to be taught, has to be learned, and is probably one of the weakest points that we have in every innovation process. So yeah, I'm on your page.
Thinking out of the box is always key, we know, in the industry. I absolutely agree. Nicola, Paone, what's your take here about data security and, of course, like education and raising the awareness within the industry?
I'm a university professor, so education is my first business. And actually, what Nicola Redi just said is probably the crucial element. Even in I teach to engineers, and the educational system to engineers is organized in vertical boxes, because we provide a lot of information about a single topic. Then it is left up to the student to put together their topics. And this is sometimes very difficult. Therefore, education should be one way to prepare the future generation of engineers, which will understand the complexity of the reality as a reality which is made of many different aspects. Reality is not disciplinary. Reality is interdisciplinary. Problems are multifaceted problems. And therefore, I think that also in the university system, we should invest a lot in incrementing the interaction between disciplines, interaction between courses. Not easy to be said, because in our educational system, we are very much structured according to rules, which are set up to guarantee a common level of education in the different locations where the university system operates. However, this very strict grid of disciplines makes it very difficult to experiment the interdisciplinarity that we need for the future generation of engineers. I'm a mechanical engineer working in the manufacturing sector. Therefore, I need to talk to automation engineers. I need to talk to information science engineers to adapt my language to their language, to be able to listen to their language and understand, not be an expert, but being able to interact constructively. This is something that is probably completely missing in the engineers operating now in the industry, because they were educated differently. And then they experimented the complexity of the reality in the manufacturing environment. The reality is really complex, and built up their own awareness. But if they, since the education part, we will invest in that, I think that the adoption of complex technologies like the digital technologies in a complex environment like the manufacturing environment will have more potential. But it is a slow process, because educational processes are long-term processes, and sometimes we would like to have the solution by tomorrow.
I agree totally. Actually, this brings me to the next question, because you know, to build an ecosystem in general, usually when you look at Silicon Valley or any other ecosystem, Israel, usually you have three main characteristics, right? The first one is the capital. The second one is the human capital, and the third one is the culture. Saying that we're talking about culture now, and so raising the awareness and education, we have the human capital here in the room. So my next question would be more on the capital side, right? Nicola has been an investor, myself as well. You guys have been inventors and also, let's say, startuppers. So deep tech has also most of the time a long period before being implemented, right? It could be 2 years, as it could be 5 years, it could be 10 years, right? And so usually for private investors, it's not that easy to follow on so many rounds or like to inflow capital on these ideas. So what I would like to ask you is that where do you see the gap per your experience as investors or as inventors within the capital market, the private capital market here? Do you think there should be more private investment, more support from governments, or more public investment? So what's your take here? It's a question for everyone, so you decide who starts.
I can start if you want. Yeah, very interesting topic. Here we have Nicola, Redi, you from Plug&Play. So I'm on the other side of the story as a startupper, and this is a very interesting topic. So in my opinion, with respect to deep tech technologies, the first point is that like it's a risky investment. That's the first important thing to say. And there's the need to expose those technologies to companies as soon as possible. So in terms of ecosystem, I truly believe that the additional point to be considered are the open innovation processes. So in order to make a startup, to make a new technology attractive also for investors, there's the need for an initial market traction. And in the industry segment, this is going to be possible only if that technology is exposed to real scenarios and to real context. So I truly believe that the first step will be to improve the processes of open innovation activities and the processes of tech transfer from university to the industry. Because by doing that, it's going to be easier for technology startups to show not only the quality of the technology, but also the added value for the industry. And I truly believe that this is a key point for investors to mitigate the risk of the investment. And then, like we always say this word in Italy, but bureaucracy is still an issue, in my opinion, for like making the process the process easy for companies, for corporate, for universities, and so on. So there's the need also to work on that part in order to create some ways for investing in startups in an easy way, in a fast way, in order to be really on the market as soon as possible. Really huge question about like the ecosystem and so on. But yeah, I truly believe that, once again, just to sum up, there's the need for better processes between university, corporate, as open innovation systems in order to get the initial traction, which is then mandatory for investors. That's my opinion.
Thanks, Marco. I don't know whether you, Nicola, Paone, Nicola, Redi, or Marco, you want to add something?
I may say something. Certainly, the technology services from universities are important, and still we have to improve in that sense, because the range of practical problems that a new company, like a spin-off startup, faces at the very beginning is extremely varied. Even if they can be trivial, they are not for people who are setting up a new company. Just consider the employment of the first employee. Is a complex step. It requires consultants specialized in hiring, managing the all the bureaucracies related to having one employee. And then safety on the workplace. This type of problems for people who is setting up a deep tech company are really complex, are really difficult, more difficult than the technical activities. So support should be improved in that sense. For example, in our experience now that we are approaching the certification phase of a product, again, certifying a product is a very complex process, also expensive, but moreover complex, and therefore support should be in that direction. Not easy to be set up, especially for small medium universities. Is not easy. However, an ecosystem requires, for example, even a simple list of certifying bodies which are somehow accredited by a university institution, so that it is easy to approach them and to interface to them. And then the other thing is capital investments. In my opinion, they are important. As important is to face as soon as possible the market. So to find links with first customers, which at the very beginning will probably be partners rather than simply customers. I think that a spin-off company should spin, but then go off quickly, as quickly as possible, because otherwise it will be a spin-in. If the spin-off company continues to behave as a university research team, it is not a company. And the company exists if it is existing on the market. And not easy to be put into practice, but that is the challenge. I'm not the real startup because I'm 60 and more old. However, the approach should be in that direction. Try to challenge yourself towards the market, and not only search for public financing. If you continue searching support from public financing to research projects, it will help you, but it will not create the spirit of a company which will sooner or later live on the market.
I totally agree, actually. The commercialization part and the commercialization phase is the most important one. When you spin out actually and you find links to customers, that's the most important part. I think here we've seen from Marco what he said is we're missing something. We need to improve the processes of open innovation. We need to improve the processes of technology transfers. We are hard certification processes, what you were saying, Nicola, and also this problem of commercialization. So starting from these pitfalls, Nicola, what do you think we can add? And from your experience and your perspective as well. Yeah, Marco, please go ahead. No, I think Marco Potenza want to say something, right? So yeah, but he's on mute. You're still on mute, or maybe it's me. No.
I can't hear Marco Potenza.
Okay. Marco, we can't hear you right now. Still. So maybe from the background, they can help us in unmuting Marco. In the meantime, maybe Nicola, if you wanted to add something.
Yeah, I was very impressed by the. Okay, Marco, go ahead.
No. Because I think that you deactivated my audio, I think, so I was not able to activate. So just sorry for interrupting, Nicola. I would like just to add something about what we talked before. I think that in the future, investors and capital should go more toward deep technology. That is, of course, it is much more risky, and it is also diverging from what we can do at university, because I agree with Nicola Paone that we are, especially now, we are teaching something that is quite far from this world, let's say, but I think it is very important. But I also think that we are on the edge of a huge revolution where machines, computers, and artificial intelligence will do more and more. And now we know that we can ask to artificial intelligence to write a code, to answer questions, and so on. And so if I think to my students, for example, what I try to teach, I teach in a laboratory. So basically I teach something that goes towards deep technology. But if I have to explain them how to do something, so let's say to make a cake by their own, it is easy. And I could ask to artificial intelligence how to make the cake. The artificial intelligence can answer, and so my students can make the cake. But if I ask the artificial intelligence how to ride a bike, for example, artificial intelligence can answer, but my students cannot easily execute the instructions to ride the bike and ride the bike properly if they are not able to do. And so I think this is basically at the center of this idea of putting the human in the middle. So we need to experience students and people to do something that is can be considered difficult, but it is that goes towards the realization of deep technology, not software or even realizing an hardware, for example, could be easy for from a point of view, a programmatic point of view. But human beings are characterized by other skills and can learn other skills very easily. And so I think that capital should, let's say, better invest on this kind of skills. So this is my opinion in this field. Thank you.
Thanks to you, Marco. And back to you, Nicola.
Thank you, Matteo. Actually, I was saying that I was impressed by Marco's, Centurioni, and Nicola Paone's answers because it's one of the first time where actually you're asking about capital, and the answers by non-investors is not on the capital itself, but on what I believe makes absolute sense. That is, how do I, especially in B2B on very technical stuff, how do I meet my prospective partners, if not customers, or usually say risk-sharing partners, that are actually helping me in building the product and going to the market. And I believe that you got exactly the point. I always say capital is like fuel. So it's not what really makes the rocket fly. I mean, you need fuel to fly a rocket, but you need the rocket, you need the astronauts, you need many things together. And we are just the fuel. I mean, capital is just the fuel. The point is how you use it. And I remember several years ago, there were various programs, accelerator programs like the one MIT was running in Portugal, where actually the idea was, I would never bring you in front of an investor unless you have found a corporate partner before meeting the investor, because otherwise it would be worthless. And this is exactly what we are trying to do, even as tech transfer investors. That is, we provide the money, but our goal is to provide the money together with the appropriate corporate links. Otherwise, even our money would be worthless. So you introduce a variable which is a key variable. And when in my presentation I said we need complex environments where to test technologies in Industry 4.0, that was exactly the aim. Let's have a real environment where actually someone who's from the specific industry tells you that works, and that gives me an advantage, that solves my industrial needs. So this is crucial. If you don't solve the need and you have proven you have solved the need, you will never get the money. So capital flows where it believes there will be a return in their investment. And we have a return investment if and only if we understand that a new technology would fit a specific market need.
Product market fit, of course. That's something that we always look for as investors, and as you said, also like the connection with corporates and with the market is extremely important. I would say we are almost going towards the end. So this is a question for all of you. So maybe one take from each one of you. We have touched upon several topics, but I would like to get from you the perspective on what you're waiting for within the industry. So looking at Industry 4.0, if you had to see it today and say, okay, I'm expecting this switch in the next 3 years, and then when this switch will happen, actually will be happy about it. I will be satisfied with where the industry, where the trend is going and where the Industry 4.0 is going. So if you had to say one thing that you want to wait for and you think is going to happen that may really change the approach of corporates, startups, or the industry in general, the ecosystem, what is going to be? Who wants to start? I'll pick one of you. Then, great, Nicola, please go ahead.
From my perspective, really a focus on humans in the production systems. If this will happen, especially for the manufacturing sector in a country like Italy, but not only, I think that the acceptance of the digital transition in the manufacturing environment would increase, and the interest as well, because operators, humans, are in any industrial, almost in any industrial process, and they will continue to be. And I think that focusing on their needs will in practice mean focus on the needs of the manufacturing where they work, of the manufacturing system where they work.
Thanks, Nicola. Marco, please go ahead.
Yeah, well, this is really a tough question to answer. I don't want to use just buzzwords, but I believe that I expect that in the next 3 years, this wave of AI is going to disrupt the market, and especially the B2B market, not only the B2C. I truly believe that this is something really new in the industry, and so I really expect huge changes in terms of processes and in terms of how companies manage the production lines, the operations, and so on due to this technology. But then also I would like I hope that what Nicola Paone was saying will also happen. So I hope that in this transformation, the design thinking approach, putting the man in the loop and to keep a user-centered design approaches would occur. That's my hope, because otherwise, with much more powerful tools and solution, without putting at the center the human, I hope that that there's the risk of many counter reactions and many bad situations. I think so. My hope is to put the man in the loop and to keep the man at the center of that innovation process. But I expect a huge transformation due to AI, and also I believe that metaverse, AR, which are the topics I'm working on, will disrupt this market.
Thanks, Marco.
Thank you, Matteo.
Nicola, Marco?
From my point of view, I fully agree that human and the man must give in the middle and the center of this process. I would like to add what is my hope, or let's say my hope is to see a better interface between academy and this industry. But often this interface has always been considered from a, let's say, too strict, too tight point of view. Let's say to find someone to be hired in the industry, that is good, of course, and to better form students to go to industry directly, that could be good. Or to form, I'm from a technical university as Marco and Nicola, to form students to economics and financial aspects. And okay, this is useful as well, so it can be very useful. But as I mentioned before, I think this is only a part of the story, and I think it could be very useful if the companies, let me say, use the university to better form themselves inside. So it could be ideal if the university could support a company mainly composed by managers, financials, economics, and so on, to better understand technology. So this could really help the company to develop better, I think. Instead of teaching economics and financial things to the engineers and physicists and chemistry and so on. And this could be a revolution that could help a lot the industry, I think.
I agree. I mean, it's one of for sure one of the most important points here. Nicola?
Well, I don't have the crystal ball. However, if I'm thinking about the next 3 years, there are two words that come to my mind. One is pragmatism, and the second is resilience. Pragmatism means it is not anymore the time where actually you buy technology for technology itself. We have seen many in the past, many buzzwords. I mean, Marco Centurioni properly mentioned AI is a buzzword. Everybody now talks about AI, but few people really understand what it's all about. And nowadays that we actually have less resources, I think that investments will be more carefully made and more focused on real resources and what resources we have and the real needs. And the other side is resilience. We are today in times where actually the world that we knew before has changed. Supply chains are not resilient, the climate is not resilient, political stability is not resilient. That means that even from a business point of view and operational point of view, we have to build system. Every company has to build a system that is going to be resilient. So Industry 4.0 must be something that actually would work whatever happens. And this might be a must for every business to work on.
So to sum it up here, for what I've heard so far, we want to have a focus on, or we look forward to having a stronger focus on humans and having humans at the center, as well as what Marco was mentioning, the developments of AI and especially the impact on several processes in the future, as well as better interface with the industries, as what Marco Potenza was also mentioning, and eventually pragmatisms and resilience, as mentioned by Nicola Redi. So I would like to thank all of you for being here together with us today. It was great be your chairperson. So I hope to see you soon in person as well. Thanks also to the audience and to the team of Tech Collider for allowing us to be here today. Now we're gonna have a coffee break, and thank you everyone again.
Thank you.
Thank you.
Ciao.
Thank you, Matteo. Bye-bye.